Hello, so in today's video, we're going to look at the function, the graph transformation of the function y equals f of x onto the function y equals f of x plus a. So this is our fourth video on these graph transformations. So what would this function look like, our sketch of our new function, when we do y equals f of x plus a, this new transformation? So remember, this is the function we're looking at, a function which looks like this roughly with this W shape. Now, if we do the x plus a transformation, okay, so what would that look like? So instead of substituting in x, we're now substituting in x plus a into our function. Okay, so let's think about this then. We've got this graph here, our original one, y equals f of x. Let's pick a coordinate, a random one, x old and y old. So an old x coordinate and an old y coordinate. So if the old y coordinate is equal to a function of the old x coordinate, which it is, we're plugging in the old x coordinate into y and we're getting this output here. But we're plugging in, when we plug in this new transformation, we're now going to plug in a new x coordinate plus a, yet we still get the same y value. What y is still equal to f of x plus a, as was y was equal to f of x. So we're still getting the same output, but we're just changing the x coordinates. So the new x coordinate plus a is equal to the old y coordinate. Therefore, the old x coordinate must be equal to the new x coordinate plus a. So this equals that. Take away a from both sides of this equation here, what do you get? You get that the new x coordinate equals the old x coordinate, take away a. So actually what is happening? Well, our new graph of f of x plus a is actually going to be shifting to the left for a positive a. So let's just look at this then. So if a is a positive number, we're actually going to be doing the old x coordinate, this one, take away a to get our new one. So let's just say that this is our new one, our new x coordinate there, x new. This is going to be x old, take away a. So basically, we're just shifting the graph to the left. So actually, it's going to look something like this roughly. So something like this, where we've basically shifted the graph to the left by a units. So this would be y equals f of x plus a, for a being a positive number. So if a was a positive number, then actually we're doing the old x coordinate, take away this positive number. So we're shifting the graph to the left. However, if a is a bigger number than zero, so maybe if a is a smaller number than zero, like a negative number, you're actually doing f of x f of x take away a number. So actually you're moving it to the right instead, because x old minus a number will give you a positive number. So your new x coordinate is actually is getting bigger. So something like this, maybe something like this kind of shape here. I know it's getting a bit messy here, but this would be y equals f of x plus a for a negative value of a. So if you've got f of x minus a number, you move to the right. If you've got f of x plus a number, you move to the left. So that's kind of how it works. Again, it's a bit counterintuitive, but the reason is for this is because of this down here. So let's write a rule for this then. So the transformation of f of x plus a, y equals f of x plus a. So again, this is a translation. So it's a um, translation by a vector, again, a vector translation of minus a 0. So actually, instead of translating by, so if you've got like a +3 there, you're not shifting the x coordinates right by 3, you're shifting the x coordinates left by 3. So you're taking away 3. If you've got a -3 as a, you're actually moving to the right. So you're adding 3 instead. So the key thing is that this is a translation of the graph horizontally in the x-axis, either to the left or to the right. And it's kind of counterintuitive. It's the opposite of what you think, because again, if this is a positive number, you go left. If it's a negative number, you shift your graph to the right. So the key thing, and the reason for that is, again, this red reasoning down here. So yeah, the key thing to remember is that this is a translation of a vector minus a and 0.